Students, in this video we are going to study a new term, that is phasor and then phasor diagram. So phasor is basically a vector that is rotating. So a rotating vector which represents a varying quantity, and that quantity must be varying as a function of sine wave, sinusoidal varying quantity होना चाहिए. Then that rotating vector is called a phasor. So what is a phasor? A phasor is a rotating vector that represents a sinusoidal varying quantity. Now that quantity can be EMF, can be current, but it should vary as a function of sine. Quantity is called a phasor. So this is how we define a phasor. Now imagine कर रहे हैं हम a vector that is rotating with an angular velocity that is equal to the angular frequency of the quantity. जो quantity का angular frequency है, let it be omega, then that rotating vector is rotating with a angular velocity of omega. Length of that vector represents the amplitude of the quantity, and projection of that vector upon a fixed axis gives the instantaneous value of the quantity. That means this rotating vector or phasor can explain that quantity completely. So first thing is that vector rotates with angular velocity which is equal to the angular frequency of physical quantity, of that physical quantity जिसको हम उस phasor के through represent कर रहे हैं. It can be EMF, it can be current. First point. Second thing, the length of this vector, length of phasor or rotating vector represents the amplitude of the quantity. तो जितना ज़्यादा length उतना ज़्यादा amplitude of that physical quantity. Third thing, the projection of that phasor or that vector, projection of phasor on a fixed axis this will give us the instantaneous value of that physical quantity. So this rotating vector is called phasor. Now the phase angle between two quantities can also be shown by the angle between their phasors. So if we represent two quantities by their phasors, by the rotating vectors, and there is some phase angle between those two quantities, then that angle is represented by the angles between their phasors. And a diagram that represent these physical quantities in terms of their phasors is called phasor diagram. So we can define phasor diagram as a diagram that represent basically जो quantities है हमारे पास, those are alternating currents and alternating voltages. So a diagram that represent alternating current and voltage of same frequency as rotating vector or as phasors along with the proper phase angle between them is called a phasor diagram. So then after phasor, what is the next point that we have to note is, if there are two quantities having certain phase angle, the phase angle between their phasors will also be same, or we can represent that phase angle between their phasors. So we can write it as the phase angle between two quantities is shown as the phase angle between their phasors or rotating vectors. Okay, so this is the phase angle between the phasors. Now come to the phasor diagram. So the diagram that represents alternating current and voltage of same frequency as rotating vectors. Now rotating vectors or phasors are the same thing, so we can also write it as phasors, along with proper phase angle between them is called phasor diagram, and it is also known as Argand diagram. So let's see how we can plot this. So here I am going to plot a phasor diagram for the quantities given by epsilon is equal to epsilon naught sine omega t. This is an EMF or a voltage, and I is equal to I naught sine omega t plus phi. Now current is leading the voltage by angle phi. So this we have to keep in mind while plotting the diagram. So these are the rotating vector. So first we plot voltage. For voltage I am assuming that its peak value is epsilon naught. So the dotted circle here represent how this vector rotate, right? This is how this rotating vector will rotate. When we are talking about epsilon, it has the angle omega t, where omega is the angular frequency of the quantity and angular velocity of this vector, rotating vector. So the displacement, angular displacement it will be omega t. So this is for EMF, and its peak value is epsilon naught. So this is the maximum value of this vector, that is epsilon naught, right? Now if we plot this for current, now current is leading it by angle phi. If the magnitude of current is smaller than EMF, then the circle will be inside the circle of EMF, and if the magnitude of current is more than EMF, then it will be outside. But we know that I naught is equal to hota hai epsilon naught upon R, which implies that I naught must be less than epsilon naught. So the circle for I naught, the value I naught must be less than epsilon naught. So I naught will be somewhere ahead epsilon naught. Now this is because the I naught has angle omega t plus phi, means it has omega t plus it has this phi extra. Okay, so I naught के लिए angle होगा omega t plus phi, while for epsilon naught it is omega t. I naught की value E naught से कम होगी by the relation I naught is equal to epsilon naught upon R. That means I naught less than epsilon naught. Now the thing, this line shows the magnitude or the amplitude, that is the maximum value of the quantity, but we also talk about its projection. So if we see the projection of these quantities on the fixed axis, so this is their projection. So projection represents, this is for epsilon, this is for current, smaller one for current, and this one is for epsilon. Now these projection will give us the values of instantaneous current and instantaneous voltages. So ये जो हमने projection डाला in vectors का on the fixed axis, this much value is of instantaneous current and instantaneous EMF for that quantities at some time t. जिस time instant पर we are observing this vector, then at that time instant its projection will give the instantaneous value for that instant only. This is how phasor diagram work. So we can explain the instantaneous value, the peak value and angular displacement, angular frequency by using a phasor diagram. So we can easily tell that in which case current is leading voltage or current is lagging behind the voltage, and this we are going to use practically while using circuits with AC source. So that's why we are studying phasors and phasor diagrams, because while practical use we need this, we need to know whether the current is leading or lagging behind the EMF, and for that representation, in that case we need phasors and phasor diagram to show the system of current and EMF. Okay, so this was about the phasors and phasor diagram. That's it for the video. Keep studying and stay tuned. Thank you.